Hello and welcome back to remote monitoring of factory data. My name is Dr. Liam Moore. I'm from the Munster Technological University based in Cork, Ireland. And today we're going to look at the applications of Industry 4.0. In previous training unit, we looked at what Industry 4.0 was and how that is the current industrial revolution that's going underway. We looked at the previous industrial revolutions, 1.0, 2.0, 3.0, and how they led up to what's happening now in Industry 4.0. But today we will look at some of the technologies of Industry 4.0, and we will also look at the potential applications and benefits of Industry 4.0 to industry. So Industry 4.0 is known as the fourth industrial revolution and is representing a significant paradigm shift in the manufacturing and industrial sector. Characterized by the integration of digital technologies such as the Internet of Things, artificial intelligence, big data, analytics, cloud computing, and robotics, the applications of Industry 4.0 are vast and span across multiple sectors and multiple areas of industrial manufacturing. In this unit, we will look at some of the more common expected applications of Industry 4.0, from smart manufacturing to supply chain optimization. We will look at the technologies that underpin these new applications. But to align everybody, first up, we will look at what these technologies are. And the first one that some people may have heard of before is IoT, or the Internet of Things. So the Internet of Things is a connection of all types of devices to the internet, spanning not just industry, but multiple sectors, from commercial to home to industrial. It's underpinned by a cloud connection and a vast array of connected devices that are embedded into everyday things, for want of a better word, everyday options. So applications this enables, it can be used for monitoring transport, freight, automotive industry, aeronautical industry. They can take advantage of the Internet of Things technologies. We are probably most familiar what we see day to day for IoT for people. So a lot of us nowadays have smartwatches, we have Alexas, we have Google Nests in our home, enabling smart houses, smart homes, and I suppose smart people. We are getting to the point of mass sensorization of the world we live in. So as mentioned previously, Alexa is something that a lot of us have in our homes, but we are getting smart thermostats, smart security systems for home applications. It's underpinned by data storage and management, so all that data has to go somewhere. We are seeing IoT in the shops and airports. Amazon trialing out RFID-based shopping, where it's cashless. You go in, pick up your groceries, and automatically charge your Amazon account as you leave. As mentioned, we have our smart homes, and we are also looking at smart industry. Due to all this interconnection of data and sensors, there's a massive growth in data availability, and all this new data is resulting in new applications and opportunities as a result. Now, we will focus on industrial applications, but this IoT is underpinning everything from our day-to-day to commercial to industry. So that Internet of Things, that is the network of devices that can be connected to the internet, enabling communication between cloud and device, can consist of a real-world interface, such as sensors and actuators, along with onboard computing, generally a microcontroller of some sort. Storage capabilities, the communications interface is key. Communications is either going to be through a gateway or directly to the internet. So gateway example would be with a smartwatch connecting via Bluetooth to your phone, and then the phone acting as your internet gateway to get the data up into some sort of cloud application. It's a growing market. In 2023, it's estimated that there are 43 billion devices currently connected to the internet, and that number between now and 2030 is only going to multiply and grow exponentially. So it's a massive growth sector. Some of the common IoT devices you might see, as I mentioned, smartwatches. We can see some of the industrial devices, industrial gateways, smart sensors, and of course we might be familiar with things such as the Nest or smart heating applications that we see in our own homes. The other technology underpinning Industry 4.0, big data. All these devices are generating tons and tons of data. 43 billion devices are going to generate a lot of data, and that creates its own challenge and opportunity on how you manage this data. Data is broadly unstructured. It needs to be sorted, stored, analyzed to be useful. And this is what the big data refers to in terms of IoT. And that's no different from industrial IoT, industrial Internet of Things, where we're going to have a lot of data being generated by the very processes that we're working on, by the manufacturing equipment. A lot of these data streams right now are independent of each other. But the drive and what we want to focus on here is the remote monitoring of factory data, where all these data streams can be collected, aggregated, analyzed, and create new insights into the manufacturing process, into your assets, into how even the product are being used and consumed by the end users to generate better value add when it comes to the manufacturing processes. Artificial intelligence and data analytics is also being underpinned by this big data and this IoT. The actual value IoT represents is determined by how the data generated is used and acted upon. And that is all down to the analytics and how it's analyzed and how the data streams are monopolized. Some examples of AI-powered IoT tools, including the Nest thermostat, Fitbit devices. So these are devices generating data and making some smart decisions, or at least presenting some analyzed data back to the end user. So in terms of the Nest thermostat that some people may have in their homes, it can learn your living patterns, it can learn your comfort patterns and adjust your heating automatically. In terms of Fitbit devices, it can analyze your sleep and tell you what your sleep quality is like, and it can give you suggestions on how to improve your sleep quality, and it can look for patterns in your data. In terms of activity, it will give you notifications if your activity is beginning to drop based on previous trends and ask you why, and encourage people, I suppose, to exercise. So this is some examples of how big data and AI come together with the IoT to offer benefits to end users and customers. So when we start focusing more on Industry 4.0, smart manufacturing is one of the first things that comes to mind. That the use of IoT, big data, AI can create smarter factories where machines, devices, and systems all work together. And a lot of the times, these machines, devices, and systems work together autonomously without the need for user intervention, because they're smart devices, they're internet connected, and you have analytics running in the background along with artificial intelligence. A lot of human-based mistakes can be removed and new opportunities created as a result. We can monitor real-time production assets as things are happening based using our IoT network. We can have predictive maintenance and conditional monitoring. Predictive maintenance is where, in advance, using the data being generated that's connected to all your assets, you can look for patterns where it will indicate that something is going to fail, and you can take corrective action before that failure occurs. In terms of cost benefit, that will allow factories to avoid downtime, to avoid potential faults in products due to poor manufacturing process, and allow a more proactive approach rather than reactive approach to process failure. Conditional monitoring is the same thing as well. Conditional monitoring is basically looking at the data, looking for certain out-of-bounds conditions where it can trigger alarms. This also in smart manufacturing will allow us to have smart and advanced product scheduling, so we can hopefully allow our batch sizes to go up and down depending on times a year, depending on sometimes even energy availability, depending on material availability. All this data is going to feed into our scheduling system and allow smarter and more reactive scheduling. We have smarter robots working with humans in collaborative settings, so that is another application of the IoT data analytics, AI all working together, allowing better human robotic collaboration for greater gains. Moving on, we also have applications of Industry 4.0 is smart supply chain. Supply chain is something sometimes we take for granted when we're working on our specific manufacturing process, our specific manufacturing area. But utilizing the IoT, we can track what's happening in terms of our supply chain from raw materials all the way into the factory. These raw materials can feed into our factory scheduling, as we talked about smart scheduling. We can track the materials through the factory and the products they're creating. And we can also track our inventory and stocking levels, which all feeds back into everything we're trying to do in a smart and proactive rather than reactive way. We can also optimize our supply chain by looking at where the finished goods locations are, so where they are in storage, working on a first in, first out basis, so we don't have goods hanging around in storage areas for too long. We could look at the conditional monitoring of the finished goods, so temperature tracking. If you're working in the biomedical space, temperature tracking could be critical of where the goods are stored and out of temperature conditions. You could react to those quicker with use of IoT tracking. This all goes to the end user. We can use smart supply chain for customer utilization and demand forecasts. This can all feed back into our factory scheduling, enabling a more responsive manufacturing process. And all of this then finally ends in recycling, where we can track our products from birth to grave and adjust what we need in raw materials into our factory scheduling. All these things can become one self-sustaining ecosystem that's more intelligent and less reactive to what's happening now. COVID is a good example of where smart supply chain could have been utilized in a lot of areas better when the supply chain's disruption caused by COVID and all the shutdowns hit. There was a lot of shifting of manufacturing processes to accommodate slower supply chain, lack of available materials, and so on. In the future, we would hope, utilizing IoT and smart supply chain, that these types of disruptions would be easier to manage and cause less of a blip in the global manufacturing settings. Other applications of Industry 4.0, we have augmented reality. Devices like the HoloLens, smart glasses, and so on are beginning to see some use within industrial settings. Able to use the large amount of data streams that are being generated by your IoT devices. You can overlay graphics, text data onto the real world in real time. This can be done via mobile phones. It can be done via HoloLens, as we have here. And what this allows you to do, maybe as a process engineer or a process manager, is to walk through your factory and you could see real-time data being generated from your assets and get a real, I suppose, snapshot of what's going on at any given time in a real factory setting, rather than just looking at a screen or looking at Excel sheets or looking at data numbers. You would be able to walk the lines and have that data overlay going on. It would also help with maintenance, where technicians and engineers would be able to, using real overlay of graphics, text, and data, get access to online instruction manuals, and they could overlay onto what they're actually working on to give them real advice on how to change things up. These are just some of the applications of augmented reality that fit into Industry 4.0. And as we mentioned, assistant maintenance, factory layout optimization is another application that's being looked at for these when rolling out new process lines and so on, that you'd be able to actually lay over the assets into the space, so virtual assets in the real space, and start setting up your process chain and your process line before actually laying down any real machinery. Other applications are energy efficiency, the ability to gather more data, allowing monitoring and optimization of energy consumption via emerging smart grid infrastructures. So again, it's all down to the sensorization of energy assets and manufacturing assets, being able to balance energy demand versus energy supply, and also helping to promote sustainable practices, identifying where energy waste might be happening within your factory setting. So there's cost savings, but also from a social perspective, you're becoming your factory or your manufacturing processes can start moving more towards net zero as much as possible. We're not just talking as well, when we're talking about energy efficiency, about emissions within the factory. We're looking at scope 3 emissions. These are other applications of Industry 4.0, trying to reduce those, again, using the underlying technologies of IoT, data analytics, big data, artificial intelligence. This can all feed into, as well, smart decisions for energy purchasing and demand forecasting for your energy as well. So you're less penalized for advanced energy purchasing. So to fully utilize Industry 4.0, you first need to have a full IoT data gathering infrastructure. So the more data you're generating from real world assets, the better. That's where the remote monitoring comes on. Ideally, you have a closed loop where you can also affect command and control down to your manufacturing line. This is slightly out of scope of what we're covering in this training units, but it's also something to be considered. You also need to have cybersecurity. With I suppose, putting everything onto the internet, you do need to secure your data and secure your assets as much as possible. Allowing uncontrolled data on the cloud is high risk. It will attract malicious actors, and you need to secure that data. And how to do that, you need the input from your IT teams as well as your automation teams. You also will want your remote access. Data needs to be accessible remotely to fully maximize varying data streams that affect factory data from all sources, need to be aggregated together and accessible to relevant users. The focus on this course is remote data access. We will look at the current trends in industry and how they are looking to get that data out of the factory and into the various applications that they want to use it on. We will focus primarily on the types of infrastructure, protocols they use and what they use to consume the data. We will start with understanding the automation environment, because that's ultimately what we're going to, as engineers, work with most. We'll look at the operational and information technology that underpins the automation environment. We're going to look at the state of the art and internal data gathering within a factory. And then we look at Industry 4.0 and various Internet of Things protocols that are being used to get that data out of the factory. There will be a focus on a technology called MQTT, or Message Queuing Telemetry Transport, and in further units we will expand on that. And we're going to look at specification and standards for data gathering in an industrial setting for MQTT. And finally, we will demonstrate this with an end-to-end data capture in an Industry 4.0 context using various technologies that we have available in our labs. Thank you for listening to this training unit. This training unit has been brought by the Project Remain, an Erasmus-funded project via the European Union. If you're looking for more information on this, please click on the link included in this training unit.